Okay, so we're going to be looking at creating the drawing for the base plate. So it does require that the base plate model is already created. So now what we're going to do is we are going to add the drawing border, and I'm going to demonstrate how to get the dimensions in place here. Okay. So first things first, I'm going to go over to SolidWorks. I'm going to pull up my model of the base plate, and then I'm going to start new, but underneath new, I'm going to arrow down. I'm going to say make a drawing from this part. So I'm going to click on that. And then I am going to click on my drawing template. This is going to be your ANSI IPS. So this is going to be inches. If you don't have the template done, then you do need to make sure you get the settings in ANSI, and then also have the appropriate number of decimal places. And I'll show you how you can, adjust that if needed, because there are a couple that some are 2, some are 3, and we gotta make sure that we're doing what the drawing is showing. Once we get here, we want to browse to where we have our WCTC borders saved. I have mine in my mechanical design, but then I go into my SolidWorks, and then I've got the borders in a folder here. This is a B size border. So if I go underneath here, you're going to notice that this is a B size border. The B is right there in the title block. So that's going to be, oopsie. That's going to be the border that I'm going to grab. So the WCTC_B, and then open. And you'll see it preview here, and then we're going to hit OK.
Did you use a C last week?
For the assembly, yes. The assembly was a C size. I think all the details are B size, if I remember correctly. Now you're going to notice that the side block kind of opens up. So we've got the top view here. If we look at how it is arranged on the drawing, we want to have what we use as our top view, which is fine. It doesn't have to be the front view. It's going to be like our, if you would, our front view or our main view on our drawing. So we're going to pull that one in here, and then in projection, we're going to put a right side view. Okay. So I'm going to click on my top view. I'm going to drag it in, and then I'm going to release, and it'll be right about here-ish. Okay. And I'm going to hit OK. Now, this pulled in for me these crappy notes. So all I'm going to do is I'm going to left click on it and hit the delete button, left click and hit the delete button. We will put them in as dimensions. Okay. So do not leave those notes in, because they are not standard. Okay. They are not to the ANSI standard. So we don't want to use those. Once we have our top view in here, we're going to go over to the drawing tab, go up to the top and do a projected view off of here over to the right. And you want to give some distance in between here. We can always move if we need to. Okay. Now, if you have your template set up the way that we had done it, you should have hidden lines as well as all of the center lines and the center marks in there. If not, you can put those in manually. You would have to do that, the center lines and the center marks, through the annotations tab. They're right here. And hidden lines, if we go back to the drawing tab and you just select on the actual view itself, if your hidden lines are not showing up, make sure that when you go down here to your display style, that hidden lines visible is checked. So if I go over, it's going to be more evident in the right side. If I go over to the right-hand side and you don't have your hidden lines in here, points off. Okay, you have to have hidden lines on all detail views. And so you change it, you just select that view and make sure hidden lines visible is there. And then we hit OK. All right, so those are our two views. Now, the other thing you're going to notice is that our scale is 1:2. If we look at the drawing guide, you need to match that scale. So if I go underneath, it is 1:2. Okay, so we can keep that in. The other thing we're going to add is going to be our isometric view up here. Okay, now this isometric view is going to be a smaller scale than the 1:2, and I'll show you how to change that. So we're going to go back into SolidWorks. I'm going to make my isometric view. You could, if you want to go to the drawing palette here, you could pick out one of these, but we can also create it from what we have here. And that's what I usually do. So I'm going to do a projected view. I'm going to click on that front view, and then I'm going to go up and to the right. I kind of zoom out here with my thing, and I'm just going to kind of place it right there. Now, here again, I don't want this view to look like this. I'm going to go back underneath. I'm going to remove the hidden lines, okay? And I'm going to make it a smaller scale. So I'm going to go up here. I'm going to kind of place it where it should go, but it's too big for that corner. So I've got it selected. First of all, I'm going to go down to display style, and I'm going to change it to hidden lines removed. Okay, so now the hidden lines are removed, which looks better. And then the other thing I'm going to do is right here in the middle, it says scale. I'm going to use a custom scale. And I'm going to change this from 1 to 2 to 1.12. I'm going to say 3. That looks good. 1 to 3. You just got to kind of play with it. It's nice to have it up there in the corner again for clarity, but it doesn't need to be huge, especially if it's taking up room. I'm going to kind of scooch this up in the corner. And then you're also going to notice that all these center lines came in, because one of my settings on my template is that all the views should have the center lines. I don't want them in this view. They just add extra lines. So you can just individually select each one with the left click and then hit the delete key on your keyboard to get rid of them. Okay. So now it's just, again, this view up here is just for clarity, and it gives us, you know, the right idea of what it looks like. Okay. So that's in place. So I'm going to do a file save. Okay. And it's going to now save it as the same file name as our model, but it's going to be now a .dwg. Okay. So you don't have to add drawing. Also notice that right here where it says part name, it's now going to be whatever I named it as in the file. Now I called it a 1 because I have more than one version of it, just because of the demonstrating and the creating. So, so that's there, but don't put in back of this drawing. Okay. Don't do that, because then it's redundant. This is a drawing. Okay. And we want to have the file name there. Now, the next thing we're going to do is fill in our title block. So you're going to use all the same information that we have down here. Okay. So I am going to go back to SolidWorks. I'm going to go up to the annotations tab and note. And I'm going to fill in my material, steel, drawn by my initials, the date. Today is 7/23/2024. And don't forget the drawing number. You have to put a drawing number in here. This is 888123. You can't make up your own, because remember, it's associated with the bill of material as well. So I'm going to go out here, hit escape, and I'm there. Now, I like to make my drawing number a little bit bigger. So I always go from 12 to 18. If you forget to do that, it's not a huge deal. But your part name and your drawing number are the two most important things in that title block. Okay, so I like to make those a little bit bigger than the rest. Okay, if you forget to do it and you still have it at 12, no points off. But you'll notice that I do that. Okay, one last real quick save. And now we're going to start putting dimensions on. Okay, now, let's go, whoopsie. Let's go underneath here. All right. There is a mix of a couple different types of dimensions here. Whenever we have I'm going to call it a regular coordinate dimension, it doesn't have anything around it. And in this case, it's just giving us the overall length of our plate. That's the 8.75. Same thing for our height here. So we're going to be putting on some rectangular coordinate dimensioning. We're also going to be putting in some GD&T. So any of these feature control frames and any dimensions with the boxes around them are associated with GD&T. Okay. Additionally, we're going to be adding some datums. All right. That's a GD&T thing as well. And then we're also going to notice that we're going to have to change the tolerance on, I think it's just that one. Okay. So I'm going to be showing you how to add a tolerance to the backside. Anything that doesn't have a tolerance in back of it defaults to our title block. So every dimension on here has a tolerance, If it's not specifically I called out, it defaults to what the tolerance in the title block tells you. So if it's a 2-place decimal, plus or minus 20 thousandths. If it's a 3-place decimal, it's plus or minus 5 thousandths. Okay. And that's dictated by your company. So different companies will have different standards. Okay. But if it's called out separately, then that means you don't go to the title block, you go to what's actually here. So I'll show you how to put that tolerance on there. And then we're also going to notice that we've got some like notey types of things. So I'll show you how to add those as well. All right, so what I'm going to do is I'm going to start by adding kind of our overall dimensions. So I'm going to go back to SolidWorks, okay? And I am going to go to the annotations tab, and we're going to use Smart Dimension, very similar to how we did it for our sketches. So I'm going to click on Smart Dimension. I'm going to left click on the length here, and then I'm just going to pull this up. I'm going to zoom in a little bit. Just left click a second time to place that dimension. Now, this is what you need to pay attention to. If we look on the actual drawing itself, that's a 2-place decimal. And how it came in was a 3-place decimal. Okay? So you need to change that. Don't leave it as a 3-place decimal because you have to duplicate what's there. So you'll notice that the menu came up for that dimension. And right here where it says tolerance/precision, you're going to notice that you see it here as a 3-place decimal. I'm going to arrow down and I'm going to go up to a 2-place decimal. And it's going to change that to a 2-place decimal. Okay. Now, if you wanted to, if you had, like, for instance, I think it was in our assignment 4, assignment 5, I think all of the dimensions, almost all of them were 2-place decimals. You could, if you notice on here, almost a lot of them are 2-place decimals. Actually, a lot of them are 3-place decimals on these. But if there was a predominant one that's different than what is set up, you just go up to your system options, document properties, dimensions, and right here in the middle is where that precision is set for the actual overall drawing. Okay, so you could set this to something other than 3 if you wanted to. Okay, I'm going to leave it at 3 because as I glance, actually most of them are 3-place. There's only a couple that are 2. So we'll deal with the 2-place decimals by just changing it manually over here. All right, so that one's in place. I'm going to do the overall height one. So if we go over here, the 6.5, that's 3-place decimal. Okay, we're going to do that overall height there. So I'm going to go up and do the overall height over here. So I'm going to move this over. I'm going to add a Smart Dimension. I'm going to select on that overall height. You could also go the top line, bottom line, and then over. Okay, so this is going to be 6.5. It remains a 3-place decimal, so that's good. Now I could either hit OK here or add another dimension. So I'm going to continue to add more dimensions. So might as well finish up what's in here. So this is a 3-place decimal here. And those are the 2 dimensions on the right side view. Then I'm going to go over to the left side view. I'm going to start on that side and I'm going to go to the center of this hole. Okay. Now, something else that I want you to be aware of is that whenever we create our dimensions, there's always going to be this gap that's created. Okay. So if I circle a corner, for instance, and you don't have a gap, that's why. We don't want our dimensions to run into our part. We want to be able to see where the part ends and the dimension starts. And that's what the gap is there for. So there should always be gaps on the edges of parts, and there should always be gaps as well from the endpoints of center points. So I'm going to put this dimension back in. Okay, I'm going to delete it right now. I'm going to put it back in, Smart Dimension from this line. If I go to, for instance, if I grab the hole itself, it's going to actually grab the center and it should give you your gap. If it doesn't, what you can do is you can move that line so that it goes to a different spot. So you can left click it and drag it. Okay. So for instance, let's say I did a Smart Dimension. I went from the center here and I went to the center hole instead of the bottom hole. Notice that my dimension goes right across that center, and now I can't see the center line for that hole. That's not good dimensioning. So what I would do is I would select this dimension, get this, and I would pull it down so it would be underneath here and release. Come on. When I pull, there we go. And when I click on it, it pulled it down. Always make sure you have a gap. All right. That's something that I always look for. So don't leave it without a gap. So watch for those. So that's our first dimension. Now, something you're going to notice about that dimension, if I go underneath here, it's got a box around it. That's called a basic dimension. That's because the location of these three holes has a position tolerance on it. That position tolerance now sets the location for those three holes, and it needs to be centered on one of these dimensions, which is the 1.2, or the 5.25. So to get a basic dimension, I'm going to go back to SolidWorks. It's really easy to add it in. We're going to select on that dimension. The dialog box comes up, and up at the top here, right by position, tolerance precision, right below none, there's basic. And if you click on basic, that box goes around it. Do not go down here where it says dimension text and put this oval around it. That means that's an inspection dimension. That is not a basic dimension. And don't tell me I couldn't find it in SolidWorks, so I put that. They mean two different things. Don't substitute. I'm going to click off of that. It has to have the box, and the box is going to be up underneath here. Under none, it's going to be basic. Okay, so you want to have basic for that one. Then we'll pull this away. Then you're going to notice that we have another smart dimension. We're going to go from that hole to this hole, and the 4.25 also needs to be a basic dimension. So we're going to go here, call it basic right away, and say, okay. Now this one, notice that my dimension didn't come down to the bottom. So I'm going to left click it, and I'm going to create my gap. I'm going to pull this down, release, and then hit okay. It didn't do it. Let me try again. Oh, it did. Yep, when I clicked it the second time, it did. Sometimes it'll show it right away. Sometimes it takes moving it a little bit, and it'll show it. Okay, so that's my next dimension. So again, use the same dimensioning scheme that's here. The next one that we have is going to be, if you click the bottom of the, if you click the bottom of the center line and the bottom of the center line, of course not, smart dimension. Center line to center line, there it goes. It'll do the gap all the time. Oh, I went to the wrong one. It needs to go to the center one here, sorry. From here to here, there we go. 2.125. And then we're going to add, that's going to be another basic dimension. And okay, I'm gonna put it down here. All right. Other things you want to be aware of, don't dimension on the part. So if you're up here, not good. Or if you're too close, don't go super close to the part. Okay, we always want to have a nice distance away. So, so make sure that you leave room between the part and any dimensions. So those are basic dimensions, okay? So if we look at our part, you'll notice that there are, the basic dimensions that we see here. I'm not going to put each and every one in, but just make sure that you have your box around each one. So I think you have an idea. Any questions on basic dimensions and getting them in place? Okay. Then let's look at some of the other things here. Let's put this tolerance in here. For this dowel pin hole, dowel pins need a nice like slight press fit so that when they go in place, they don't move around a lot. So you're going to notice that the size here is 0.375 is the size of the hole, but we're going to have it as a +0 -1000. Okay. So to show that in there, we are going to put it in as a smart dimension to, a smart dimension to start. Okay. But then we're going to be changing the tolerance. So I'm going to go in as a smart dimension. I'm going to click on the outside diameter of that hole, and I'm just going to place it right about there. Okay. Now, my dialog box opens up. The number of decimal places looks good, but now I want to go to my tolerance. I want to switch it from none to bilateral. Bilateral. And then down below this is where now a new dialog box opens up. Right now it's at a +0 minus, and I need to change it from -1 to minus, I'm sorry, from -0 to minus 0.001. Okay. I'm going to hit enter and notice that it adds it in there, right? And I can just hit OK. So that's how we get that in there. Let's look at our threaded hole. Now, before when we got rid of that note, we need to add it back in, for instance, for this threaded hole. So I'm going to go to Smart Dimension. I'm just going to click on the outside diameter of that threaded hole, and it recognizes it's a 3/4-10 UNC, perfect. But then we want to just finish up the note. We want to add in front of it 2 by, and then after it through. Okay, so that we know we're putting it all the way through and not to a depth. So I'm going to go back. Now, as we look, that we want to activate and make sure that this dimension is blue and that this is the information for it. Down here is going to be the dimension text. So if we click on that and we go right in front of it. So for instance, if you click anywhere in there, you can arrow all the way to the left, and now you're in that text editing mode. Right in front of it is going to be 2 by. Now, make sure that it's in capital letters. So mine wasn't. I'm going to put my caps on 2 by, and then we have to put a space, and it'll do it on the screen right here. Make sure there's a space. And then we're going to go after, so after the UNC, we're going to go space THRU, so that we know that there's 2 of them, 1, 2, and they're both going to go through. Okay. And then we're just going to hit OK. All right. Now, below this, we need to add a feature control frame. So our feature control frame for this is for position. It's right here. Okay. So we are going to go back to SolidWorks, and on the annotations tab, all the way over kind of to the middle of the screen is our geometric tolerance. The top one here is going to be a feature control frame. So I'm going to click on that, and I am going to place it first. It'll want to kind of grab something. Don't worry about grabbing it. Make sure that you're off to the side so it's by itself. And the first box here is going to be our symbol, which is going to be for position. Our next box is going to be a diameter symbol, and it's going to be, we do not want a leading 0. In ANSI inch, we don't have any leading zeros, only in metric. This is an ANSI inch print, so it's going to be 0.013. Okay. Then we need to put a projected tolerance in back of that. No leading 0 in ANSI prints, ANSI inch, only in metric. That's a dimensioning standard.
Why 0?
A leading 0, if it would be 0.013. Yeah,
Okay.
yeah. Leading 0 is in front of or to the left of the decimal place. No, I'm glad you asked. Then we need to add a condition or a material condition modifier. So I'm going to click on this. Oh, where's my P? Dang it. Wait, feature. Hold on. Oh, there it is. Sorry, it's under feature, not material condition. So we're going to go and directly in back of the 13, we need to grab that P with a circle. That's a projected tolerance. So we're going to go feature. We're going to click on P. That's going to be right in back of it. That means that the tolerance is projected outside of the part, not into the actual feature itself. And then after that, we are going to add right in back of the derived. In back of the P, we're going to be 2.50. And then we're going to add a material modifier right here. So you go from feature, the 2.5, then material modifier, maximum material modifier. And then we need to add a datum. Our first box is going to be datum A, and then we're going to add a new one, and it's going to be datum D. And we're going to be done. So let me do that one more time if you didn't quite get it. So I'm going to delete it. We'll do it one more time. Geometric tolerance. grab down here, position, diameter, 0.013. Then we're gonna go to feature, projected, right and back 2.50, so that's 2.5 inches projected outside. And then we're gonna go to material modifier, maximum material condition modifier. Then we're gonna add the datum. A is our primary, add a new one, D is our secondary, and then done. Okay, I'm gonna click off of it, deselect it. Now what I wanna do is I want to left click on it and go over the top of the dimension to kind of select it on that dimension or that note, and I'm gonna release. And now what it does is it attaches it to the actual 2x3/4-10. So now if I move that note anywhere, my feature control frame goes with it. If I don't do that, if I move anything on that drawing, I'm gonna have to then separately move the feature control frame. Okay, so that one's in place. Let me look at the part. You're gonna notice the very same thing for this threaded hole. And then this hole over here, there's a 3x and a through after. All right, so those are gonna be similar in setup, and then feature control frame as well. Let's do that one. I'll do it another one so that you see it on here. So I'm gonna go to, let's see, smart dimension. I'm gonna go to the middle hole here. I'm gonna pull this all the way out, diameter 0.938. Our dialog box is up here. I'm gonna go down to dimension text, go to the very front 3x, because there's 3 of these holes, and then space through. So notice that it develops that right here on the screen so you can see how it looks. Say okay. And then we're going to add the geometric tolerance, the feature control frame below. This again is going to be, this is a position tolerance. Diameter 0.014. No projected tolerance on this, so we're going to go right to material modifier, maximum material condition modifier. Then we're going to add our datums. These happen to be A. Pulling it up. The second one's going to be a B. And then one more. It's going to be a C. And then we can say done. Left click off of it. And then reselect it, left click, and drag it over the top of that note. And now it's going to attach it to that leader so that if we move this anywhere, the GD&T goes with it. Okay, so that's right about there. And then the other thing we need to do is add some datums. So I'm going to show you how to put this datum in place here, datum D. So you're going to notice that in the middle of the screen here, annotations tab, right below the geometric tolerance is the datum feature. So we're going to go to datum feature. We're going to select on the perimeter of that circle, and then it attaches, okay? And then I'm just going to go, I think this is where I put it, right about there. And then I'm going to change my label. Actually, you can just hit escape, reselect it because it went to another one. And I can just go from A, I'm going to change the label up here to D. And then enter. Now, this is the deal. If you don't have your ANSI set, this is not going to have a leader on it, or not going to have a what do they call it? A landing. It doesn't have a landing on it. Okay. So if you have to, you're going to have to go up to your system properties, into your document properties, make sure you're on ANSI, but then you're going to have to go into each one of these and make sure that they're all set to ANSI, not ISO, because ISO still sticks in there. And then you're going to go to, I think, detailing, and make sure that, you know, you have the settings that are here, the center marks and stuff. Virtuals, I think that's it. I think that's it. So make sure that those are to ANSI. Otherwise, if it doesn't have the landing, it's not to the standard. Okay. Let's put in a flatness. There was a flatness over here with a datum on it. Oops, I see that there's a question. Hey, Kelly, why isn't datum D a part of the feature control frame for the 3 holes? Oh, this is why, Ben. So datum D becomes a datum after it's positioned. Does that make sense? And we have it here because we want the center hole to be the datum for other things, not the full set of 3. Does that make sense? We could put a datum down here, but that would mean then the full set of 3 would be the datum. In this case, we just want only that center hole to be the datum. So does datum D only control the middle one? Yes. Doesn't control it. It's assigned as datum D for, like in this case, the 3/4-10 to be positioned on. So now what's happening is this dimension right here is going to be centered with datum D, the center hole there. Okay, that makes sense. Good. All right. Let's put the flatness over on this side over here and then add a datum to that surface after we have it flat. So again, we're going to do a geometric tolerance. We're going to left click away from things. We're going to add flatness. And in this case, 0.005. Again, no leading 0. It's not a 0.005. It's 0.005. And then we're just done. Flatness is a form tolerance. It does not get any datums at the end of it. So we're going to hit OK, unselect it. And then we're going to add a datum feature. The datum feature, we're going to click on this feature control frame. And then whether you go up or down with your cursor is going to set the placement. So we want it to be underneath here. It sets it as E. I'm going to double click on that. And this is going to be A. So don't worry about, you can always go back in and change that. Now we want to attach it to that surface. So we're going to left click on this and we're going to select that dimension. And I want it to, oh shoot, I don't want to do that. I had to undo, did it wrong place. Undo one more time. I'm going to go to the side surface here. There we go. So don't click the inside like I did. You got to click the side. And then we can just pull it back on the side. You can go up on the top with it. You can go here. I think this is where I have it on there. And you can always move this. Make sure when you show this datum, don't put it right up against the triangle. Pull it down so that there is a landing. There has to be a length of a landing. That's to the standard as well. It can't just be triangle and then the datum. Okay. So let's take a peek at our drawing. Are there any here that you're wondering about that as you look that we did not cover yet? So we put on basic dimensions, we put the tolerance in place, we put on some feature control frames, we put on some datums, we put a datum on an actual feature. Are there any other dimensions that you see on here that you're unsure of how to put in place at all? And I'll watch the dialog blocks as well. Okay. So we didn't do the full one here. There's still some more work to do, but I think we did examples of everything that is on here. Okay. So I'm going to leave you with that on this particular drawing. Okay. So again, making sure you're filling in the title block, the part number, adding in the views as you see them here. And then again, duplicating what you see, basic dimensions, 2 and 3 place decimals, tolerances that might be there, adding datums. And we did a couple examples of that here. So I am going to stop recording and then I'll take any questions.